In this video, we want to look at what is Coulombic energy. Of course, generally in physics, we know what is Coulomb's and we know what Coulomb's law states. But now, when we talk about Coulomb's law or even the Coulomb's formula, we know that the potential energy is created by electrostatic interaction or electrostatic interactions between charged particles, and this should be equal to what would the formula PE, which will be given as Q1 Q2 divided by R1 squared. But that is in terms of the electric charge. But now we want to relate these to the nucleus. What would be the Coulombic energy in the nucleus? It is given by, you can watch the previous video for explanation on the surface energy. We have also done the volume energy. This is the Coulomb energy. So it is always given by V, which is equal to 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught into E squared divided by R. Don't worry, you will know how we get all this. Let's say that there are 2 protons. For 2 protons in the nucleus, we are going to have V to be equal to 1 over 4 pi epsilon naught multiplied by Z. Of course, you know Z is proton, into Z minus 1. Z minus 1. All this multiplied by E squared, divide by 2. Divide this by 2. Multiply this by 1 all over R, which is the average energy. We are calling this average energy. So how do we get all this? If we do our simplification, this will give you, if we do our simplification, this should be equal to Z into Z minus, this is Z minus 1 multiplied by e raised to 2 divided by 8. It becomes 8 pi, because we know here we have 4 pi epsilon naught, but this gives us 8. When you do simplification, this is 2 here, 2 multiplied by this 4 will give us 8 pi epsilon naught into 1 all over R, which is the average energy. And this will be the expression that we want to derive, that will help us establish what Coulombic energy is. Now let's take this 1 over R so that you know how we get this from. We know that R is the radius of the sphere, but here we are referring to this as our average energy. So take 1 over R, which is our average. This should be equal to the charge 1 all over Q. Integrate this from R, which should be equal to 0. So this capital R, VQ, which is the charge, divided by R. Rho will be equal to Q. We know rho is equal to Q divided by 4 all over, this is 4 all over R, 4 all over small r. Then we have our pi R cubed. So rho is nothing but Q divided by 4 over 3 pi R cubed. Now let's bring them together and do our integration. This will be 1 all over R average which is equals to 1 over A. 1 over, this is 1 over Q, sorry, which is the charge, the integral from 0, because we know R is equals to 0, so it is the integral from 0 to R, from 0 to R of rho multiplied by this 4 over 3 that we have here. We have 4 over 3, so this is going to be 4 over 3 into pi R cubed. This is basic integration. Divide all this by R. Let's bring this out. If we bring it out, we will simply have 1 all over Q that we have here. Multiply this by Q into 4 over 3. 4 over 3 pi R cubed. Bring it this way, and this we are going to be left with the integral from 0 to R, capital R, of 4 over 3 pi 3 R squared dr, so that the denominator will simply remain R. When you look at here, we've got Q and Q, so this can cancel out. Here we also have 4 over 3, and we have 4 over 3. That can cancel out, so that what we are left with is 1 all over capital R cubed into the integral from 0 to R of 3R dr divided by 1. So now we can go ahead and do our integration. Our integration, if we integrate this, we need to integrate whatever we have here. We want to integrate this. We want to integrate this. If we integrate that, we will simply have, let's pull this 1 over 3 out as it is, 1 all over R cubed. The integral of 3R dr will simply give us 3 R squared divided by 2. Of course, it is from 0 to R. This will be 1 all over R cubed multiplied by 3 over 2. This is 2 R squared. This will give us 3 all over 2R. This is cubed. So what you will get is 3 over 2R. This is simply integration. So therefore our V, remember what we are interested here, we are looking for Coulombic energy. Our V will be nothing but those 2 protons, V into V minus 1 e raised to power 2 divided by 8, as I indicated earlier, by epsilon naught into 1 all over R. I simply wanted to show you how we get this 1 all over R, which is the average. So how do we therefore represent our Coulombic energy? Our Coulombic energy, which is always given in terms of EC, will be nothing but negative A3. Remember, our surface area was negative A2. So now our Coulombic energy is nothing but negative A3. Z minus, that is Z into Z minus 1. All this divided by capital A, which is the mass number, raised to 1 all over 3. And this is what we call the Coulombic energy. This is what we call the Coulombic energy. So you can go through it again just in case you get confused on how we get 1 over R, which is the average energy, and impute it here so that we are able to get the Coulombic energy, and then you're good to go. See you in our next video.